Hello, my favorite algebra students. We're going to start off this week with something that I think is so much fun. I hope you think it's fun too. We are going to graph quadratic functions in vertex form. So if you don't know what I'm talking about, that's okay, because vertex form is a brand new form. So let's just review for a second here. We have a quadratic in standard form, y equals ax squared plus bx plus c. And how would you graph that? If you remember, you need to use the x equals negative b over 2a. Then you need to plug that in. And we also use the a rule to find two other points. Then we also learned last week how to convert. Sometimes we can convert to the intercept form. And if we have the quadratic in the intercept form, how do we graph that? Well, if x minus p is a factor, x equals p would be a 0 or an x-intercept. And so would q. So we would graph the zeros of the function, and then we would find the vertex, which was a little bit tricky to find the vertex. Some of you missed this on the quiz. To find the vertex, you're going to go halfway between these two zeros, plug that value of x in, and find out where your vertex of your parabola is and graph. All right, and then the last form that we're going to talk about is called a vertex form. So here it is, y is equal to a times x minus h quantity squared plus k. Now for most of our examples, our a will be a 1, so you won't see this too much. Just like in intercept form, we never had to factor the a off. The a was always 1. For this year, our a's will be 1. When you get into Algebra 2, you'll be dealing with some a's that are not 1. And I'm just going to show you a little bit how to do that. Anyway, if you have a quadratic in vertex form, it's called vertex form because your vertex is the point h comma k. So let me see, I'm going to grab my highlighter. Your vertex is the point h comma k. That's your vertex. And then how do you get your other 2 points? We could just use the a rule again. So if it's given to us in vertex form, I hope you can still see that's an h and a k. I didn't mean to cover them up completely. If you're given this in vertex form, the graphing's really pretty easy. What's the trickiest part? The trickiest part, do you see this minus here? And do you see how this is a regular h? So the h is opposite its sign. The k is the same, right? But the h is opposite the sign. All right, so let's just go ahead and graph a couple of equations in vertex form. And by the way, I am looking on page 611, so it's not an actual section. It's on page 611. Okay, so here we go. We have y is equal to x minus 2 quantity squared plus 1. What is our h? Here's our h, and here's our k. So our vertex is going to be the point. Do you see how it's minus 2? So our h is a regular 2, and k is 1. So let's go there. We go to the point 2, comma 1. We look at the a. Our a is 1, so we can move 1 to the right and up 1, and 1 to the left and up 1. And lo and behold, we have our parabola. We could label these points. The vertex is the point 1, comma 2. If we move over 1, this would be 2, comma 3. And this would be, oh, I'm sorry, this is 2, comma 1, 1, 1, 1. So this is a 2, Oh boy, I goofed that up. Sorry, 2, comma 1, go one more. This would be 3, comma 2, go back 1. This point would be 1, comma 2. Sorry about that. Notice that we don't have the ax squared plus bx plus c, so we don't know what c is here. We can't check what the y-intercept is, not with the vertex form. But you can see that was pretty easy to graph. Let's try another one. This quadratic is already in vertex form. Here's our h. Do you see this plus? So do you know what h is going to be? H is going to be a -1. So that's the x coordinate of our vertex is opposite this number here. And our k is -4. And then what's our a? A is 3. We'll use this for the a rule. But first let's go to -1, -4. 1, 2, 3, 4. So here's the vertex. This is at -1, comma -4. It's always nice when you label those for me. Now the a rule means we're going to go 1 to the right and up 3. 1, 2, 3. So that's the point 0, comma -1. And then go 1 to the right and up 3. That would be at -2, comma -1. And we have our parabola. Whoops, missed that point a little bit. It's supposed to go through there. Anyway, pretty good. All right, so that's the easy part, class. The easy part is graphing from vertex form. The more difficult part is if you're given an equation in standard form, how do we convert it to vertex form? And the answer is we must complete the square. So we just learned completing the square. To solve, now we're going to complete the square to convert from standard to vertex form. Now this is tricky. It's a little challenging, but I also think it's pretty fun. Slightly different than when you had your equation here equal to 0 and you add the perfect number to both sides. Slightly different. So let's walk through this. We have y is equal to x squared minus 8x. This 11 is a junk number. It's not my perfect number. I'm just going to scooch him over here. I'm going to leave a place for my perfect number. If you remember, the perfect number is half of b squared. So we're going to get the perfect number of half of b over 2, and then we're going to square it. That's our perfect number that we're going to add in here to make a perfect square trinomial. So half of 8 is 4, squared is 16. Remember, it's always positive. Well, what have I done to this equation, this balanced equation? I've added 16. So I could add it to the other side, but would that really get me vertex form? Do you see how it's y and everything's on the other side? So here's a little trick. This is what's a little bit different with this method. We add the 16 in here, and then we subtract it off. Pretty interesting, right? The net effect is 0 there. Now we want to factor this perfect square trinomial. Remember, we want it to look like this up here. So we've got a binomial that's squared. So x minus 8x plus 16 factors into x minus 4 quantity squared. We've done those a bit. Hopefully that was okay with you. And then now just add these two together. 11 minus 16 is -5. And voila! We have converted from standard to vertex form. Now we can sketch a graph. Can you guess what the vertex is? Did you say 4, -5? I hope so. 4, -5, 1, 2, 3, 4, 5. I got to get down there far enough. Okay, so here's my vertex. It's the point 4, comma, negative 5. Remember, it's always opposite. Inside the quantity, it's opposite. That's positive 4, negative 5. Our A is 1. So if we move 1 to the right and up 1, and 1 to the left and up 1, and we can sketch the graph of our parabola. Great. Let's do one more. Actually, I got 2 more for you. Do you see how the negative is here? We never can complete the square when we have a negative coefficient in front of our x squared. So the very first thing that we need to do is we need to pull that off. So I would have a positive x squared. When you divide by a negative 1, it's going to change the sign. I'm going to leave room for my perfect number. And guess what? Do you see this 2? It's not inside the quantity, so it just remains a plus 2 over here. All right, let's find our perfect number. Our perfect number is half of 4 squared. So 2 squared is 4. It's always positive. But now here's tricky. Do you see how the negative 1 is out here? And I added this 4. In effect, what did we add here? In effect, we added a negative 4. Do you see that's a negative 4? So what do you have to put over here to counterbalance a negative 4? That's right, you have to do a positive 4. That is tricky. All right, now let's factor. The negative 1 remains on the outside. Let's factor that trinomial. This would be x. This is minus, so minus square root of that. Add these together. And there we are. H is 2. K is 6. That's our vertex. 2, 6. So let me give myself some room here. 1, 2, 1, 2, 3, 4, 5, 6. 2, 6 is right here. When we apply the A rule, A is negative 1. So when we go 1 to the right and move down 1, and 1 to the left and move down 1, and I'm going to go ahead and label these points because I want you guys to do that with every problem. This would be the point 1, 5 over here. And then sketch the graph of our parabola. All right. And I did promise you that I would show you one where the A is not 1. And just like we factored off the negative 1 over here, we're just going to factor off the 2 here. So if I factor off the 2, I would have an x squared minus 6x, right? Leave space for your perfect number. This 19 is a junk number. The perfect number here would be half of 6, which is 3. Squared is 9. All right, I'm going to give you a minute to think about this. In effect, when we put the 9 there and the 2 is here, what have we really added to this side of the equation? We've added an 18. So we need to subtract 18. And then we factor. Half of 6 is 3. You could also take the square root of 9, right? Half of this number or the square root of that. And then positive 19 minus 18 is plus 1. Let's go ahead and graph this. H is positive 3. K is 1. Our A is 2. So if we go 1 to the right, we're going to go up 2. 1 to the left, up 2. And here is our parabola. And I could go ahead and label these points. If this was 3, 1, this would be 4, add 2 to that, 3. And go back once, this would be 2, 3 over here. All right, not too many problems. I hope you take your time, and yeah, I hope you enjoy these. Let me know if you need any help. Take care.